Okay, so let me just show a video. Nicole, just in case you don't know, actually we are on this topic, electricity. And then we started like 2 weeks ago. It's not something new. That's why we are not doing any more teaching. It's going through of the worksheets. Okay, then I think you tried the worksheet. Is that right? No, attempted is actually 0. Okay, you have not done it, huh? Don't worry, because maybe you're not familiar. Okay, Jocelyn didn't have time to do, right? Yeah. We will be going through the questions. Okay, if you're both not familiar, then we just go through it slowly. But there's something that I want to show you about the ammeter. If you remember, Jocelyn, we did talk about connection. Okay, and how it's going to be like if, let's say, it's connected wrongly. So if you look at what I'm sharing on screen, all right, so yeah, Jocelyn, you did the practical already, right, in school. Good. So that's how the connection is. And you realize that if you connect it in the wrong way, some lemon juice one. I see. Okay, so if you connect it the wrong way, then it will go negative. Say, not to worry. A lot of students not mindful. They even wrote down minus a negative value, no? Okay, you're actually supposed to switch the wire. Then we talk about resistor. So what is actually a resistor? Last lesson, we discussed a little bit about resistor. Okay, so let me just quickly show you a video, all right, about resistor. So take a look. Resistors are very important. In fact, we have it in our daily life. If you are not sure, you watch the video and you probably can recall a bit, because this worksheet we're doing is on resistance. Okay, so this is about resistance. So why am I showing you that video? Is actually to show you that resistors are used in everyday life, even if you don't know it. Okay, Jocelyn, remember I did talk about the dimmer the last lesson, right? The lightings at home. So if you want a romantic kind of ambience, you can actually adjust the lighting, right? So you can turn the knob into very dim light, then very romantic. You want it to be very bright, you turn the knob the other direction. So that's all controlled by a resistor. Okay? Show you one more video before we go on. Yeah, it's very interesting. We can play around with it. You can even make your own science project. Okay? Your own science project. Okay, my kids actually built, you can buy those model houses, yeah. Okay, Nicole stress. Okay, you build those model houses, right? Then you can include your lightings inside, so you can adjust the lighting accordingly. Okay, let me show you that powerful resistor he was talking about. Okay, what happened to my Zoom? You can still see me and hear me, yeah? Can Suddenly I can't see. Okay, the Zoom is back. I'm going to quickly show you this very interesting, huge resistor he mentioned.
Hello. This is a rheostat.
Okay. So we call it a rheostat. Just like he said, his father-in-law worked for, his work revolves around the elevator, the lift, and then there is this very powerful resistor he uses, right? So this is the one. Let's see how this thing works. Okay, so if you look at this part, okay, maybe I just explain a little bit to you. Okay, this is known as a variable resistor. Another name for variable resistor, okay, is a rheostat. He mentioned the word rheostat, right? So that is representative of variable resistor. What is the meaning of variable resistor? That means resistance can be changed. It can vary from small to high, high to small, using just one gadget. Okay, you don't have to like remove it, change another component where you have a higher resistance, then you remove it and change it to a lower one. No need to. Just one variable resistor, we can control how much resistance we want in the circuit. Why do we want to control resistance? Some of you might be thinking. Okay, we control resistance to limit current flow. Okay, or we can increase current flow. Okay, so the word resistance means not allowing, like blocking, correct? Not? If somebody is resisting you, that means blocking your way, don't allow you to pass through. So some form of resistance is there. So when there is no resistance, things pass through easily. You can walk through a path easily. When there's high resistance, it's not easy for you to move through. Same for current. When there's high resistance in the circuit, current can't flow well. Okay, little current flows. Then if you have no resistance, then current flows freely. Right? So in this case, if you are looking at the diagram now, what's happening here is this rheostat is made of this coil of wire. So it's really going in turns, coiling the whole area over here. So these are called resistance wire. They actually have some form of resistance in them. The longer the wire is, the higher the resistance. Okay. So this is a tab. It says that it's a tab, right? Just now the person he said that this is a tab. This is a metal rod. Okay, so what happened over here? If I connect the wires across the two ends of the metal rod, this is a complete circuit. Current just flows through here. Okay, you can see into the wire, to the battery, which, flows through easily, continuously with no problem. Okay, so the current will flow. You can see my mouse moving, is just flowing through. Okay, a complete circuit caused by these metal rod. Then you see the light bulb here, very brightly lit. Okay, so no matter how he was trying to turn or push the knob here and there or the tab here and there, there's no change in the brightness of the light bulb. However, okay, when he connected this way, okay, totally, this light bulb cannot light up, right? Remember I told you this is the resistance wire? If you have the whole coil here, it is very high in terms of resistance. Current can't flow. So this bulb, right, would never light up. Okay, then if you are connecting correctly, okay, if you are connecting correctly, that means one wire connected to the end of the resistance wire, the coil here. Another wire is connected to the metal rod. So what happens over here is, how come electricity can flow? Okay, in this case, you don't see the bulb lighting up. Okay, why is this a correct connection? Let me explain. Remember the current, right? You say conventional current flow, so it flows out. Okay, but then because the resistance is so high, look at how long this wire is. It's not one straight wire only, it's coiled. Okay, so every coil is like the circumference, right, of these two. So there's actually a very, very long distance. So the wire is extremely long. So there's a high resistance in this particular path. Current can't flow. So you don't see the current flowing through the whole thing due to the high resistance caused by this wire. The wire is too long. So then he adjusted, right? Okay, he adjusted. Look, okay. You can see him adjusting to this part. The bulb lights up. Not that bright yet, okay, but at least it is lit. Okay, so Justin, this is the romantic light that we have. Okay, this is the romantic light that we have. How did it happen? Okay, so, all right. So this part here brighter a little bit, right? Because he actually shifted a little bit to the left side. So as he shifted a little bit to the left side, now the path that the current is flowing is through here. Look at the mouse, my mouse moving. Then it goes through this metal rod. Okay, and then this is the conductor also. So it's connected to the coil here and then go round and round and round and round. and it will flow through this wire and back to the battery. So there is current flowing. The resistance is not that high because the distance here for the, or shall I say the length of the resistance wire here is not as long as just now. Okay, so when he adjusts more, okay, so let's see, when he adjusts more, wrong side. I think this is the part. Can you see here? The moment he actually plays the tag at this point, do you see that the resistance wire is even shorter now? Okay, lesser coil, right? Maybe just about six turns. Okay, so the distance of that wire, the length of that wire is not so long now. So more current can flow because resistance is lower. That's why the bulb is brighter. So that's how our dimmer light works. You turn the knob, you're adjusting the resistance. Okay, understand now? Can understand better about how this kind of lighting works. I used to have this in my primary school classroom. So when I do mindfulness activity with the students, okay, I will dim the lights. Okay, then close their eyes. All right. And then so that after the whole activity, when they open their eyes, it's not like suddenly it's so bright, right? The classroom. So after they are done with mindfulness, they open their eyes. It's not so bright. Their eyes have time to adjust to the brightness. Then I slowly turn the lights brighter. So that's how dimmers work. A lot of students will say, hey, magic, teacher, how come you can have that? Hey, there's no magic. It's because of the resistor. Yeah. So if he actually connects in the opposite direction, same thing lah. Okay. So how the lights gets brighter or darker, it all depends on where he is placing this tab. Can you understand better now? Okay, Jocelyn, understand better now? Sherman, can you understand how it works? How the resistor actually works? Yeah, you guys will understand this a lot faster. I'm not kidding you. Nicole, do you understand this part? Good. Yeah. So very interesting. It can also be used to control the volume. You know, the traditional radio, right? Okay, you have to carry. Last time they have cassette tape, then we have the CD player, then we can play radio 98.7, all right, 92.4. Yeah, all these radio stations, you must have been listening to the songs, right? How do you adjust the volume of your radio? Again, it is the resistor. Okay, so the knob that you turn for the volume is actually working this way. All right. So if you're asking me about the brightness of your handphone, now you understand how come the screen can be so bright? How come you can adjust it by, pressing certain adjustment? Do you get it now? Okay, last time you don't understand how come we can adjust, right? Adjust the brightness of our handphone screen, the volume. It's all about resistance. It's everywhere in our life. If you don't know, now you know. Even the microwave, you adjust the temperature, the oven you use to bake your cakes and biscuits, cookies, all the same. We make use of a lot of resistor here and there. That's why I wanted to show you those videos, okay? Because that's how things work in our life. Very interesting, but we tend not to pay attention until we come to science lessons. You learn more. If you ask your parents, they wouldn't understand, or should I say that they wouldn't know how to explain to you. Okay, so now you, in fact, can explain this to your parents, how this works. Okay, so let's look at the first question. The first question is related to the first video I showed you about the connection, right? Okay, so how do we actually connect the ammeter and the voltmeter? Now, if you cannot recall what I've taught before, Jocelyn and Sherman, okay, Nicole, don't know whether you're at this topic in school. Okay, primary school, we don't learn about the connection of the ammeter and voltmeter. Yeah, because I taught in both primary school and secondary school, I know the big difference between what they are learning. Okay, so we will always connect the ammeter, okay, ammeter in series. You might want to take notes